Hello, my name is Julia Joy, and this is my ArcLink project. So, for this project, the path I chose was New Milford's baseball field. My friends and I come around this baseball field all the time because there is a small park with swings next to it, and after we go on the swings, we decide to run around the field as a way of exercise for ourselves. So, in order to calculate the length around this baseball field, I would have to figure out the length of the curved side of this baseball field, along with adding the straight edges of the field. In order to do that, I had flipped that path around so that it would look more like a graph on an X and Y plane. And then I used the measure feature on Google Maps in order to find the coordinates of 5 specific points on the curved side of this path. So the 5 points marked are 0, 182, 50, 173, 95, 147, 150, 90, and 186, 0. With these coordinates, I had plugged them into the graph program. And on the graph program, after the 5 points were plotted, I had gone onto the options that there were, and I added a trend line. And in order to find a trend line that was as close to the original path that I had chosen a polynomial graph. And as seen when I chose polynomial graph, as compared to the original, they're pretty similar, the curved sides of the baseball field. They're pretty similar in most aspects. They're a little off, but it worked for me. And as seen at the top, the equation of this graph was given. So I took the equation of the function that I had plugged in, and based on the coordinates. And I had gotten negative 0.0068605 x squared plus 0.35421165x plus 178.479711011. So I'd taken that equation and I had taken the derivative of that to be used in the ArcLink formula. And the derivative of the function was negative 0.013721x plus 0.354211165. And then I took that derivative of the original function and I had plugged it into the ArcLink formula. The ArcLink formula is that the length is equal to the integral from a to b of the square root of 1 plus the derivative squared dx. So when I plugged in my numbers into this formula, it became the integral of 0 to 186, which was the span of x values that I had to deal with, of the square root of 1 plus the derivative squared dx. And when I plugged that into my calculator, I had gotten that the length of the curved side of the baseball field was 196.5 feet. Then, in order to see how much I had differed from the actual length of the path, I had calculated the total length of my path. So the calculated length of the arc, as according to the ArcLink formula, is 196.5 feet. And the other two side lengths of the straight edges of the field were 186 feet and 182 feet. When adding those three lengths together of all the sides of the field, I had gotten a total calculated length of the path being 564.5 feet. And as foretold by Google Maps, the actual length of the baseball field all around is 662 feet. Just to see how off I was from this actual measurement, I had taken percent error. And when I had done that, I had gotten around a 15% error, which is not too bad, which shows that the ArcLink formula worked more in my favor in this, and I had gotten a pretty close answer to the actual length. Thank you for listening.